Geometrical meaning of the zeros of a polynomial. In this module, you will learn about the geometrical meaning of the zeros of a polynomial. Polynomials are the algebraic expressions having the exponents of the variables in whole numbers. A polynomial can have one or more terms. If Px is a polynomial in x, then the highest power of variable x in Px is called the degree of the polynomial Px. Depending on the degree, polynomials can be classified into different types. Linear polynomial, which is polynomial of degree 1. Quadratic polynomial, a polynomial of degree 2. And cubic polynomial, a polynomial of degree 3. If Px is a polynomial in x and k is any real number, then the value obtained on replacing x by k in Px is called the value of the polynomial Px at x equal to k. This expression is denoted by P of k. Now, the real number k is said to be a zero of polynomial Px if Pk is equal to 0. Now let's look at the geometrical meaning of the zeros of a polynomial. Consider a linear polynomial ax plus b where a is not equal to 0. Here, the graph of the equation y equal to ax plus b is a straight line which intersects x-axis at exactly one point, that is, minus b upon a. The x-coordinate of the point at which the graph of the polynomial intersects the x-axis is called its zero. Thus, a linear polynomial has one zero. Now, consider a quadratic polynomial ax square plus bx plus c where a is non-zero. The graph of the equation y equal to ax square plus bx plus c is a parabola either open upward or open downward depending on whether the value of a is greater than 0 or the value of a is less than 0. The zeros of a quadratic polynomial are the x-coordinates of the points where the parabola intersects the x-axis. There are three possible cases while studying the shape of the graph of a quadratic polynomial. In the first case, the graph cuts the x-axis at two distinct points a and a dash. Here, the two zeros of the quadratic polynomial are the x-coordinates of a and a dash. In the second case, the graph cuts the x-axis at one point. That is, the 2 points a and a dash coincide each other. So, the zero of the quadratic polynomial is the x-coordinate of the point a. In the third case, the graph can be either above the x-axis or below the x-axis. As a result, the graph does not cut the x-axis at any point. Therefore, there is no zero for the quadratic polynomial ax square plus bx plus c. Thus you can conclude that a polynomial of degree 2 has at most 2 zeros. If you plot the graph of cubic polynomial function y equal to ax cube plus bx square plus cx plus d, where a is not equal to 0, then you obtain either of the graphs shown. From these graphs you can conclude that the graphs of cubic polynomials intersect the x-axis at 1, 2 or 3 points respectively. So, a cubic polynomial can have at most 3 zeros. In general, a polynomial of degree n has at most n zeros. In this module you've learnt algebraic expression in which the exponents of the variables are whole numbers is called a polynomial. The highest power of x in the polynomial px is called the degree of px. Polynomials of degree 1, 2 and 3 are called linear, quadratic and cubic polynomials respectively. A quadratic polynomial in x with real coefficients is of the form ax square plus bx plus c such that a is not equal to 0. A cubic polynomial in x with real coefficients is of the form ax cube plus bx square plus cx plus d such that a is not equal to 0. The zeros of a polynomial px are the x-coordinates of the points where the graph of y equals to px intersects the x-axis. A linear polynomial has exactly 1 zero. A quadratic polynomial can have at most 2 zeros. A cubic polynomial can have at most 3 zeros. A polynomial px of degree n has at most n zeros.